Alright. So now we look at a rolling the dice problem again. They're saying there are two. So there's number one, number two, and what we've done, you can go 1, 2, 3, 4, 5, 6 on the purple die or something. 1, 2, 3, 4, 5, 6 on the green die, or however you want to call it. And what we're doing is showing you the different combinations we can have, right?
Yeah.
So what they're saying in this table is that 3, 1 is different than 1, 3. There are actually two of those. So on the test or homework or something, you can kind of memorize this. It doesn't take, you should be able to visualize what it looks like, or quickly write something like this out on a test. We're going to leave it in what's called reduced fraction form. So they want you to do the math, enter, enter, if you need to reduce your fraction. How many possible outcomes are there when you roll 2 dice?
36 possible combinations.
Because there are 6 combinations on the first one, there are 6 on the second one, and you multiply it. Because really they're in what they're called independent events. If I roll 1, you roll 1, what I roll has no effect on what you're going to roll. What is the probability of getting 2 numbers that add up to 12?
$136.
Yep.
Only one of those combinations is actually a double 6. So
Yep.
that's probably rolling 2 6s, 1 out of 36.
Yep. So, one possible combination will get you to 12. Right down there in the corner, 6 and a 6. So the next question is, what is the probability of rolling 2 numbers that add up to 5? So when you look at the table, you'd go through there and circle the ones that are 5s.
It's 4.
So there's a 4 and a 1, a 3 and a 2, a 2 and a 3, and another 1 and 4. So we have
436.
4 out of the 36 possibilities. So when you do that, you go 4 over 36, reduce that, divide both of those numbers by 4, you get 1/9. Let's say that I will give you $100 if you can predict the sum of the 2 numbers on the next roll of the dice. What should you bet will be the sum of the 2 numbers? 7. And Robbie, why do you say that?
Because there's more options to add up to 7 than anything else.
Right. Right along the here. So if you look at a table like this, the diagonals really are telling you the sums. And if you go up that particular diagonal, 7 is the most common outcome you could have when you talk about sum. That's why the Vegas game craps is played with 7 and 11. Because you're going to roll a 7 again before you roll your number more often. So there are 6 of those, right? A sum of 7. And there were 6 out of 36, correct? So you have a 1/6 chance of rolling that particular sum. Versus a sum of 12 up above, you only have 1 shot of all 36 possibilities. So that's a huge difference. So I'm going to stop again, pause it, and you're going to do 5, 6, 7, and 8 on your own. Read the question carefully, use the table, reduce your fraction, and then I'll put the answers up there in a second. All right, so let's bring it back to 5, 6, 7, and 8. You got time to work on them. What is the probability that you roll doubles? Henry T.
1/6.
Can you explain how you got that? How many ways can we roll doubles?
636.
right? Double ones only happens once, double twos only happens once, double threes, so 6 ways out of that total table, and you said 1/6 with your reduced fraction. What is the probability that you will not roll doubles? Peyton?
5/6. Like the remaining parts of the table are not doubles, so like if it was not reduced, then I would have said 30 out of 36.
That is called the complement. So depending on how you looked at it, if you guys were, circling things on a table, if somebody says, how many ways are there to not roll doubles, and you went through the table and circled 30 things, you'd be better off saying, well, let's figure out how many doubles there are, circle 6 things, calculate that probability, and then do the complement. So what do complements always add up to?
Each other.
The 100% in probability. So don't confuse this with complements out of, geometry and stuff where it's adding up to 90 degrees. Complements in probability will always add up to 100%. So it's kind of what's called the not event. What's the probability that at least one of the dice shows a 3? So up above, how many different boxes had a 3 in them? Body.
10.
How many?
10.
10? Is that what people are getting?
Yeah, I got 11.
Let's go up and look.
I'll go 6 by 5.
So we're looking for
6 by 6.
We're looking for the 3s anywhere. So there's one there, one there, one there, one there, one there, one there. Right?
Yeah, that's 6.
There's one there, one there, one there, one there, one there.
But wouldn't you count that one towards the 340?
No, because it's the same roll.
Yeah, but it's a different dice.
No, it's not. You only
It's still dice number 1, dice number 2. You can't. It doesn't happen. Otherwise, each of these doubles there'd be 42 possibilities. There's only 36. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
What? How is that reasons?
11 out of 36, and that cannot be reduced. And then finally, what is the probability that the sum of 2 numbers is an odd number?
That's a guess.
You got 18. Is that
So
good?
that's 1/2 sweet. So good.
Half the numbers are odd. We agree?
Yes.
So the first day of these probabilities, we're not doing a lot of rules. They're just some calculations, intuitive thinking. Just go through the stuff, try to figure out what you're doing. If you have to draw, a table out, like to see what it looks like when you roll the dice, do so. Okay. Do that homework assignment out of the book, and